Hello everybody. It is time for a new live broadcast of some coding work I'm getting ready to do. And you can see me here in the HTTPX site, learning about how to use it with the context manager. Whenever you see the with keyword in Python, it means it's with the context manager. And this is a way to do what so many of us know these days as import requests and then requests.get and then some URL, okay? And then of course we set some response object. So often R is used for that. So, you know, this is what Python developers are used to. This is what we're used to for fetching HTTP and parentheses web pages, right? So Kenneth Wright, I think it is, the guy who developed this. Requests is so big that just a search on requests would always bring that up in the top position. Kenneth, this guy here has had a profound impact on Python. I think he's working for Heroku, I think, comes to mind these days. We could follow that, but that's a tangent. The important thing here is that he set this trend of for humans, right? So it became a very popular interface for doing web page fetches because the stuff that's built into Python, variations on URL-lib, are supporting of all the various edge cases that might have to be done in Python. So it's got a complex API, a much more complex API than, say, languages like Ruby, where one-liners for web page fetches are built in. So it's very typical. On my last video, I got you up to that point where I was fetching the HTML for every page of my website. I was also timing it as I went and printed the amount of time it took on these 700 or so pages. So at the bottom of this, we'll see it took, you know, just under 2 minutes to fetch the HTML of all these pages. Now, as you'll recall, it didn't really fetch the HTML except for a few pages because of the lack of trailing slash. So I have since gone into that file. So cd Mike 11 ls vim index, and so this is the home page of that website. And you can see all these URLs are listed here. If I go to the end, you'll see the slashes are there. I just basically used this text editor that I use to go in, and I wrote a macro and it just spun through and put all the trailing slashes. So now when I do that experiment that I did in the last video, it really populates it. And you'll see here that I'm printing, you know, the internal counter number, the status code of the page fetch, and the length of the data. And I'll just expand that. So you can see everything which previously had 301s as permanent redirects is now 200. So my site is in much better shape for SEO. There's also a few other little happy details of this change. Namely, in that database that I kept showing you that kept growing. I have all those windows still open. I haven't closed these since yesterday's video. That file is just about 7 megabytes now, 7 megs. 6,936 kilobytes is 6 megabytes. And we can confirm that going into that directory cd.ls-la. It's going to be near the top. So here's the file A something. Here it is, A something. So this confirms it. It gives a different reading, but I guess it's because of the way Windows reports it on the desktop and Linux reports it. There's different ways of looking at code blocks and stuff where the bytes end, you know, actual byte blocks or bytes occupied on the machine. So anyway, it's about 7 megabytes of data from crawling my website. Now you see me really in the thick of things here, And what I need to do is, instead of looping through link and links, I should be able to throw all the links at a function, and it concurrently just fetch those links and pull it back. So that is why I have this page loaded, because it's one of the advanced features of HTTPX, one of the API compatible replacements for the requests package that's out there. And in using the context manager, it accomplishes something very similar to what we with requests know as session objects. So this is a client object. It recycles cookies and all kinds of stuff. It avoids a lot of scaffolding, building, and destroying that's happened on every HTTP connection by recycling the environment from the first call in the sequence. So I had done an implementation of this before in my old package that I'm copying everything over from, SEO Kata. And you can see here is my old version of get responses. And there's a few things I don't like about it. Of course, here's one of those blind try passes. But there's other things in here. First, they changed the internal naming. I had to import async client from HTTPX with a statement up at the top, and I think they've changed their internals already. This is part of being on the bleeding edge of taking up packages before they're even out of beta. But here's the command from HTTPX, import async client. I only did that because a camel case word like that is so hard to remember. I didn't want to have to remember httpx.async client with that capitalization stuff. Ugh, I hate that. So it turns out that in the new example, it is just client, right? Capital C, I can remember that. The uppercase thing here means that it's a factory model. So, you know, it's okay, just as long as it's one word and not two. So, okay, how to actually go here. They're giving really good examples. This is wonderful. So I'm debating whether to copy and paste from their examples here or to use my examples. Although I do want to point out one of the problems I had, one of the reasons I'm refactoring it a bit, is if I had a list of URLs I was sending to it, right? Oops. We close you out of that. Maybe I edit that later, but you know, no big deal. Yeah, so I'm coming out of work and had this on my mind. I got up to a coding spot that's really, really important to share because of the very heady issues going on here with reworking this function, right? So that's what I'm actually doing down here, and I've actually built it up quite a bit that it's not a great point to join in on. So I'm going to just go above this and show you what I'm kind of doing here. First, you know, a function called foo that returns bar, right? So if I just go foo, it's a callable, so I need to put those parentheses. Bar answers back. And so what I'm going to do here now is, let's see, make another function. Def, example. Okay, example is going to, let's see how I want to go about showing how this works. Yeah, so much good stuff built up here. The thing I needed to answer is if I could feed a list in there, so the requests, and a function name, func. And because I want the function name to be optional, I'm putting equals none. And that says this parameter is optional. And now I can return, say, just the function, returning a function, right? So this is an interesting thing because now calling example with, say, a list in here, 1, 2, 3, and a function name, which I conveniently have there as foo, it will return the function named foo. I could return the calling of the function. So we just put the callable thing there. I've redefined example to return calling the function that comes in. I execute this, bar, right? Now, function could easily act on everything coming in. So since it's requests, I can say for item in recs, and I'll return a little table, the standard trick of making table equals empty. And on each iteration, I will return, I will add to the table, table.append. Let's make function take input and return. We'll use an F string. We put an F in front of that, which means I can just arbitrarily put a variable in here. So it's returning the word bar plus whatever was input. And so now on each append, I will append func calling the item. And instead of returning the called function, I will return a table. Bar 1, bar 2, bar 3. This is the basic trick that what I'm doing down below is based on. And I really needed to show you that because, well, let me actually show you how I'm going to be returning a list of tuples. It's jump ahead, right? So input, output, input, output. I'm just going to quickly bring this one up here a little closer to this so you can get a notion for how when I put a list of URLs in there, what I went back is actually the list of tuples, right? I want tuples returned, which contains key value pairs, with the key of the key value pair being the URL that got sent in on recs, right? And the output of a function item. So it's going to look a little repetitious because, you know, the ones are going to, well, I just show you, right? Okay, something not defined, func. Okay, so the URL that gets used to make the request, the response object from HTTPX, URL response object, URL response object. This way, I have a very standard way of keeping what made a request and the answer to the request paired up so I don't have to coordinate them later. That was my big mistake in this other implementation. It basically just returned get responses. I think I even had it in there. So this just returned the URLs, the fetched object, the actual thing that was sent back from the get method of HTTPX into a list. It appended them into a list and sent back that result set. So this list comprehension just is a one-liner. It's beautiful, beautiful. I'm actually going to be a little bit challenged. I'll have to shape it as a tuple here in order to send them back the way I want. So it's a really good example, though. I have to change the nomenclature, and I'm putting it in async mode. That's a really important thing to for me to check here. So it tells you, oh, in the documentation, I guess I want web. In the documentation for this, it's showing you how to use the context manager first, but then it's got to show you concurrency soon after that, because the whole reason for doing this is to make the concurrent requests. Relation as client get. Interesting. Okay. Async. Oh, I wonder if things have changed that much. If you're using, and then you need to be aware that the hooks register and must be async functions rather than plain functions. But I don't see the context manager being used with the async keyword, which is very interesting. It has to do with deferring the call. So maybe they're not deferring the build the actual fetches by leaving async. I'm going to have to experiment. You're going to see me experiment with that, right? So this is pretty awesome stuff. From my prior time, I know how, the 100 and some seconds to do all those fetches, right? Because here's the fetches. It's not using the context manager, so it's doing all the new sort of connection work on every request. It's very inefficient, and I'm cycling the user agent, which really doesn't help that. I might not cycle the user agent on my new implementation. Yeah. Okay, so I explained what's going on down there. I don't feel too much of the need to go and rebuild it all, but I am saying that return value equals false. Okay, I will go through it all. Use function equals false. That's a default setting. It's assuming that no function came in here. But if there is a value set for function and that function is callable, then use function equals true. If not use function, we check if what came in here is just a string. Because if it's just a string, you got to put square brackets around it, because everything I'm doing is intended to work on lists of URLs or lists of tuples optionally. So then I do a list comprehension. It's not even a list comprehension. This is like, oh yeah, there's a list comprehension in there. So I'm feeding the all function all the URL contents of the recs object. So recs get fed in, and then it says all of these must evaluate true, or else it returns saying input must be a list of URLs, right? So if there's no function provided, that has to be a list of URLs, and this checks it and steps out of the program if that's not the case. So that whole table and appending to table is going on here. Here's a resps response or a resps table instead of table, so that it has a little better language as it goes. And then I'm appending a tuple here. So if usefunc, so if a function has been provided here, then it's going to return the rec plus foo. And if a function hasn't been provided, it's going to return the rec and the word bar. And the example I do right here is with a list of URLs that are not URLs at all, but I have links. This will be a lot of output, but you'll see, what is going to cause the request and what the output of the function is going to be. And really, I don't show the output of function. I just hardwired foo and bar, but I have that foo function up there. Oh, I redefined foo. I'm going to get rid of that foo because that's not as good of a foo as the foo above it. So now I can use that foo, which takes input here, and use the foo function, and return bar. Oh, well, I'll put a little thing here. I'll make foo take input and oh, well, no, I only do use the foo on one of them, right? Yeah, of course. Semantic correctness. I don't want to actually use foo on both. So if use function, then foo, and I'll feed in the rec. Why not? And otherwise, it's bar. And so now the output, bar, because there's no function fed in. But say I was feeding a function in, oh wait, there is a foo function fed in, bar. Yeah, right. It's outputting the output of the function, bar plus that, bar plus that, bar. So every URL is repeated. That is, in fact, the output of this function, because there's your bar right there. Otherwise, it would have just been a single instance of the URL. It would have been rec. So if I can take this out and show the other way, show it going through, there's going to be a bar in there, but each URL is listed once. So that's enough to satisfy me. I don't know if that did any good explaining it to you, but I will be returning a list of tuples from this function in every case. It'll always be a list of tuples. In one case, it'll be a URL and the actual response object from HTTPX that was provided. In other cases, it's going to be usually that same thing, but the output of an arbitrary function that takes this as its input. And it doesn't even have to be URLs. So I am going to have to make a list of tuples in order to demonstrate it. Like, I guess I'll do search requests. That would be a natural one. So concurrent search requests. Boy, I should probably run a VPN before doing this. Maybe I won't use search requests for the example. That would make this video too long and perhaps confusing. So what I'm going to do is make a list of tuples right now. Tuples. You can use plural. You can't use singular because it's a reserved keyword, but you can use plural. Tuples equals, and it'll be a list, and inside of that list it'll be, let's see, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Easy to type, easy to look at, and now I have them around for use. So I could say for a tuple in tuples, print a tuple, right? The most basic loop, and then it just prints one for each. You could also do list comprehension. This is, I guess, for people who are just getting into this stuff. You could put, first of all, you put square brackets around tuples, and then you can say x for x in, and now it'll return just as if you were to put the word tuples itself there. That's the same output as that, except you can do things like, oh, I don't know, let's sum it. And so that's showing the output of the sum function for each element in the list. You could, of course, do that here, but you can see how much more elegant list comprehensions can be. You can take this and you can use this different places, like as the input of functions and stuff. So you could do list comprehensions here. But anyway, I have my list of tuples now, which I'm going to have to do this very same test, right? So if it's tuples, use the provided function name. So I do want that foo function down lower. It's no good here. And in fact, this guy doesn't even need to exist. You get what's going on there. This is distracting. This is where we set it, so we'll keep it. You've already seen this. We'll get rid of that. We'll get rid of that. Too much to look at. Clean up as you go, my friends. But now I do want that foo function that I just copied into my copy buffer sitting there. And execute it over and over. There's really no harm done because it's not fetching things. It's just outputting 700 some URLs, which Jupyter does real fast. So let's see. Think. Yeah. So if use function, then use the function. Else, just output it. But now we don't have to do the bar. We're going to output just the double URL is an indication that a URL was provided. That's going to be, double URL. So if a function was provided, this is actually the very code that I want. We'll just change what happens here to returning, say, the sum of the input. Input looks like it might be a reserved keyword. I probably shouldn't be doing that. In is reserved as well. A tuple, just to get the syntax right. So you can see it's double URLs out there because of this one here. But if I put foo here now, yeah, you can't unsupported operand. Yeah, of course, I'm feeding links in, and I'm trying to sum the links. That's pretty stupid. Tuples. There. So here is the outer list. I should try printing that. And I think there's a p-print thing. It works differently than it used to. It has been turned off. Oops, and then another one. Yeah, I'm going to have to get used to this new p-print that's built into Jupyter. So it's not doing what I had hoped. I hoped to get some indenting here and stuff to show you a little bit more of that structure, but I can point it out. It's returning the key that went in, the sum of those values, and the key and the sum are both its own standalone tuple. You can count parentheses with open, open, close, close. See, open, open, close, close. That's a tuple unit right there. It happens to have a tuple inside of it, but the tuple that's in that outer list is what's highlighted in blue. Similarly, here's another tuple. The input that went in, this guy here, and then the output that came out. So because it's hard to look at these things, one of the fun tricks is to use named tuples. Named tuples take a little bit of getting used to. You're making kind of labels for things, but I think that this is a worthwhile divergence because I do want that to be up in my sort of global includes here. It's just a matter of time before I import named tuples. So let's do it. From collections, import named tuple. All right. And so now it's always a little bit tricky to do this, but it goes something like, let's call these chords, right? Because it's XYZ chords. And so we're making a master class chords, and we're making it equal to a named tuple. Let's see if I can get it right. There's going to be two pieces of input. The first, and they're both strings, interestingly. They can be a string in a list, but the first one is going to be what you call this by, and the next one is going to be what labels you want on each thing. So let's just say it's label X, Y, Z. I think commas are even optional. It could be just spaces between it. But I now just defined something called, chord, which takes as its input X, Y, and Z. So that place where I define these tuples, I'll save myself some typing. Now that I have this named tuple, named chord, I can just put that in front of these tuples. Now they're going to be named tuples, and they will have labels. Print. It's not through vowels yet, but I'll print it right beneath it so that the point can be made without any extra stuff. X equals 1, Y equals 2, Z equals 3. Chord X equals 4, Y equals 5, Z equals 6. It doesn't make sense to sum coordinates necessarily. However, lots of good information here. Print val is still going to print the old value because it hasn't gone through the function, which I believe is up here. And now maybe I can just run it, right? And go back down to where we viewed the value. Yeah, it sets value, right? So this one here should really be right up here beneath it. Print the values. There is our input. our input was this named tuple. It's certainly easier to read now, right? Because the inner tuple is a named tuple. So there's chord x equals 1, y equals 2, z equals 3, and there's its sum. Here's the next one, and here's its sum. So the reason this is important is because tuples and named tuples can be used as keys in a dictionary, keys in a database. So you'll remember in my examples, when I was crawling the site, and I would say, for link and links, for each URL that you encountered, you both want to get that response, and then you want to use the link as the database key and use that to pull up the response. Now, that's all well and good, except sometimes your database key is not going to be a URL. It's going to be a bunch of arguments that are going into a function. And the very best way to store data for later retrieval is with either the exact URL that fetched it or with the exact input parameters to the function that fetched the data. Your input parameters to function should be able to be used as a key in a database. This can be a tuple, where it's position sensitive to have meaning, or it can be a named tuple where just looking at the key itself will give you all sorts of insight as to what kind of data that key is going to pull out of the database. Okay, so this generic function I'm building is going to work on either a list of URLs or a list of tuples. I alternate between tuples and tuples. I don't know, GIF and GIF. So if it is a function, I might actually have written it. This might actually be, oh, well, no, the concurrent request has to occur, right? Whatever's going to happen in here is going to use this sort of stuff in a list comprehension. There's going to be probably 2 list comprehensions. I don't think I'm going to be able to recycle the exact logic, and I don't feel like externalizing it into a function. So I think I'm going to be taking that thing over here. I didn't find async, but here's the syntax for maybe you do need the async client. Maybe I'm totally wrong in looking at this example and thinking they simplified it. Now that I dig deeper into my mind, I'm thinking that they might be giving an example on how to do synchronous use of this tool, which also has use. Async client. There, see, async client. Let's see what that has to say. Yeah, here's that async keyword. So let's start out with that. This is a good example code. We hit that example. And I could steal it from my own code from before, but I'm going to force myself to rethink it. So this lower one is easier because it doesn't have the tuples in it. I thought that would not be part of what I copied. Unpleasant surprise. Okay, so async with async client as client. So I will have to do that. Oh, well, I don't have. I imported the whole HTTPX object. So this is the exact syntax I need, what gets lifted off their site. Await client get, and it's just a single URL, right? See, this is not what we want. It's going to be the whole list of URLs here. It's concurrency, right? That whole list that gets fed in gets processed here, churning as fast as it can, getting those responses. So I'm just going to make a grab for it. There should be the word gather. And there is not the word gather. How could they have this documentation without teaching how to do gather of marshalling results. Ugh. Anyway, I take back what I said about not using my own code as my copy and paste example. I'm going to have to, because they don't have this, $1 million pattern in there. This is the $1 million pattern. Await, gather, asterisk, dish stuff. Return exceptions equals true, says whether it quits out automatically when it gets an error or not. So it's true by default. So really, just this, to keep it as simple as possible. People are like, oh, Python, concurrent requests, it's so hard. Well, that's because you got to know which package to use, HTTPX as it turns out. And you got to know the magic incantations. Like, most people can't think through this. It's hard for me. But of course it's, we don't want a for rec and recs. That's now obsolete. And we certainly don't want all that table concept going on there. Responses. We don't want this. We're going to rethink that. We don't want that for rec and recs. And so we if not use func. This is the alternative version. So we outdent that by 1, and we get rid of that appending to the table that was taking place. And this is indented too far, but I'm not even sure if this has any meaning now. Atup equals now. So this is, if not use func, if use func. Ugh, right? So already, ugly, ugly. If use func, else. And it's much prettier. If not, you want to avoid, if you can, just you check if, because that's why you made this stuff up. So use the language that you meant to, be beautiful, right? So if use func, it's going to go through this, and that's not what, I have 2 else's. If, we got to fix that. Oh, I see. That belonged to that use func up there. So this is a path that needs to be gone through if you're about to process the URLs. So, and I have the asynchronous piece. If use func, right. So pass. Get this to a nice spot for worrying about the tuple case later. After all that explanation of why tuples are in this picture for input requests, I'm going to actually focus on the URL type, because there's a lot of important magic here. I'll put a space here because how different this is. So if use func, follow this path. Else, did you just feed a string? Then the request is just that string as a list. If not, then get out. If not, return. I just say it's ugly to look at that thing. Must be URLs. I'm just going to say that. It makes it so much easier just to look at that. Just a little bit. In fact, RV equals, right? One return position. You'll serve yourself well if you always have one exit. If typing must be URLs, and then it should exit there. I gotta, if not all, RV. Yeah, it's a case where it's just so much simpler. Just return it there. That's okay. That's okay. Okay. All right. Now on to the important thing. If it survives to this point, then it has a good list of URLs it's going to work with, and I want to make sure I have the right words in there. I certainly don't. It's recs, right? So take out URLs. It's requests, because I want to keep the syntax good. It might not be URLs. It might be tuples, which represent get rec singular, because we're making this up. It's arbitrary. That's list comprehensions. You might not see it right here, but it's X for X in list. big list being Rex that comes in here. And, you know, this is going to change because that's not the name it has anymore. It's going to be this. Go for as on the beaten track for readability as I possibly can. And this is concurrent response gathering. Now, one of the things that is some mental gymnastics I'm going to have to do, and I'll probably end up fetching these URLs more than once, but it shouldn't take too long because it's concurrent. R equals, oh yeah, I'll just set RV right there. RV equals all that populated and then return RV. Let's just try it, right? And we will send in links, and we won't send in a function. This is what we're testing right now, with links but without function. Return RV is async with a very interesting. Cannot parse async with as client. Return, it's the location of return RV. You think this through, think this through. Gather needs to be closed. Okay. Async with outside async functions. Def, I believe it's async def or def async, one or the other. Async def. It's like heavy metal. Async def. I should have put a timer on it, but it's already done. That could not be. Oh, it's a coroutine because it wasn't awaited yet. So this is deferring the whole crawl. It's so interesting. So now there's a possibility that I just need to say, you know, vals equals await val. And this might be my crawl, but it's not. Gather is not defined. I need to import gather. Gather is something I imported from up here. Yeah, there it is from async IO import gather. Ugh. So it got to that, right? It got to that. That's a really good sign. And try that again. And I'm going to try and clean this up because, you know, how I feel about this. This is all the example code. So as functions get written, they get moved up into what gets imported. Boy, watch my prior video on NBDev if you've got any curiosity about what's going on here. Let's call this, it needs better syntax. It's not just vals. It's, you know, fetched. It's awaited. Awaited val. Ah, there it is. I should have put timing on that. We might be sitting here for, look, nice. A for above. Let's look at those awaited vals. Not bad, not bad, right? That was an asynchronous fetch of every page listed on the home page of my site. So if you don't get the idea here, mikelev.in. This is my my website, and as you scroll down it, you start to get to, and it's hopelessly outdated. I got to tell you, I need to really update this. But you start to get to these lists of links, and so this is the list of links that I crawled with a function that I added to mlseo on the last video. And so now I'm actually fetching all the pages that are listed here, and they're actually, you know, real pages. Some of them might be very small, but all of them are actual pages that I had published at some point in the past in WordPress, and then I converted them over to GitHub.io. I exported them to static files, markdown files, And so a lot of what I'm doing these days is really based on that fact. A lot of my work is centered around that fact now. Microsoft bought GitHub. Boy, I have, things to resolve. I am not happy about that fact. But at any rate, Control-Shift-R, because of the keyboard shortcut we put there in the last video, which is restart kernel and clear all outputs, nbdev auto doc building, the name of the exported package nbdev will use, the uncompromising PEP8 code formatter, a little bit of documentation about what I'm trying to accomplish here. The pip installs that have to be done in order to make what I'm showing you here work. The imports that are also going to be exported to the package. I imagine there will be some I don't put in there in the future. The functions that are going to be exported to the package, and then just work stuff like setting a test URL, asserting that the URL is good, extracting the apex, and those are asserts, so if it gets through here, it did well. There's a user agent thing here, which is really, I guess, being tested in this one here. It's another assert, fetching just the home page of my site. And then here is the creation of a database with fetching just the home page of the site and making sure that the resulting file is a file. And so we do that, and you'll notice that the file size doesn't change. It's still like 7 megabytes because that's just re-putting in the content of the home page. It's not like nuking the database. This is kind of like a one-page crawl right here. This takes that text that we, the response object, the whole response object, and uses the view source, the HTML of my home page, and extracts the links. I could show you that, but this one here now fetches in sequential format and populates the link for linking links. Oh, this does the sequential crawl. I guess I better start labeling this stuff. Performs sequential crawl of links. And in parentheses, that's a one-page site crawl. One-page site crawl? Yeah, one click depth site crawl is what's being accomplished here. So people say writing a crawler is like this big deal. This is going to spend those 2 minutes and fetch all those pages. But I'm actually trying to do something different than that. I am going to skip this step because doing it concurrently now does it so much faster. This function is almost something I could copy up there into what gets exported. But it's a big but. The object that comes back is just a list of the response objects. I need it to be a tuple, and I need to understand this asterisk and how to turn this into both the key that's being fed in, because it's gathering for each rec, right? So rec should be able to be picked up and put over there. And I use tuple notation to put both the output of this get, and I'm answering my question. That turns it into a tuple, and then rec here should turn it into a key value pair tuple, and that asterisk there is a splatting function for gather. It's taking each element of this list comprehension and feeding it as a separate input to gather. So you can use a list comprehension in gather, and you can splat it to make it as if it were a bunch of separate inputs. Yes. So this should work. Boom. Again, I should probably time it. Oh, wait, yeah, I don't have to. Let's do the timing now. Let me pick up that timing syntax because I was very interested in the timing when I was doing the sequential crawl, and that's still there. I didn't execute that code block, but here's the timing code. So you just set start equal to time, and end equal to time again, and then end minus start gives you the number of seconds that this took. All right, so this will await that request. It has been deferred in here. And I could probably get rid of the deferring so that each time this thing is called, it finishes the concurrent, the fetching before it returns anything. Because right now what it's returning is a promise, right? That promise is sitting there. Without further ado, fulfill the promise. Future coroutine of an awaitable is required, right? So await value equals await val. Awaited val equals await val. Good syntax. Did I just not run this? Okay, so it's working a little differently now than it was before. I am pretty sure that I did everything I was supposed to. I have imported my libraries. Those are all imported, including the gather that I needed. We saw it actually work once. So whether promises are still being awaited or not is a source of some ambiguity. I'm going to take away the await here. Yeah, but then it doesn't make any sense. I'm going to just try printing the value. Yeah, it's a coroutine object. Get responses at awaited equals val. Await underscore val equals await val. So it thinks it was already awaited. Well, let's change this name here. Let's move that out of where the function is defined. Call it val2 and print val2. Okay. Was never awaited. It wants an await in here. I thought it would. I thought it would. Now it should come back not as a promise, but as a fully populated thing. And the timing then really has to be on a statement like this. Oh, await goes in here. I am totally taking back what I said. We want it like that. Value 3 equals doing the await out here. That way we have the option. We control whether we await it or not. Okay. Type error. Coroutine is a coroutine or awaitable is required. I thought that was awaitable. See that right in there? That's awaitable. Get responses. Rex func. Val3 equals await. The error messages an async future, a coroutine or an awaitable is required. And that is on using the await keyword there. It's really surprising. I am going to restart kernel. It's always a good idea to restart your kernel. 7, 8. 8 runs gets me to where I should be able to go down here. I might merge those cells in the future to make it less clicks. Oh yeah, links is not defined, so links needs to be created. Here's my links. Resp is not defined. Yeah, I guess I do want this one executed. We want that sitting in memory. So I populated my lists. I got that error again, but we're going to build this up. Links. I know I have good URLs. So that's going to go down this path and then go into here. I know it's going into here. Right? So one thing we can do just to test this is copy paste. It's the actual HTTP fetch that makes this expensive in any way. Oh, I turned this into the tuple, so what's coming back could be related to that change that I made. But I can just make this a concurrent, writing out rec as the response. If I put that here, there's a right. So what I would do is rec for rec in, and so this is a valid function, and this is going to do a lot like what I was talking about before with just putting two URLs. It's not even two URLs. It's going to be two URLs because it's key and then value. It's that, Nope, it's just returning a list of URLs. If I get back a list of URLs, this is actually a success. Try that, becomes a coroutine, right? So we try await that. It's the actual executing of it, but it creates an error. So something inside the function is definitely written wrong. This await is what it doesn't like. An async IO future, a coroutine, or an awaitable is required. So once I use await and gather, it's expecting something in here to actually be using to have the concurrent thing implemented, the async thing. So putting it inside a tuple kind of broke. I just put it back to what it should be, and I do believe this will get rid of the error. It's going to actually create the promise now, and then the other code I was using with the timing, this should suddenly now be very doable. Although this promise isn't set to anything, so I have to say val equals go back to exactly the way I was doing it before. Yeah, so it's referring to it again. It was sitting there as a promise. Let's see if doing it a third time. Yes. There's like an alternating. It's like a modulo thing going on. But this should actually not do it. Object list can't be used in await expression. Oh, it's already been awaited. This is what I meant to time. Jesus. Okay, we're very close. I'm telling you, we're close. This first time it's going to generate an error. No, now it's working. Okay, I'm going to get the timing. 3 seconds. 3 seconds versus close to 2 minutes. Let's take a look at val, see if it's what I expect. And there are a bunch. There's a couple of, see, I want to see the URL that made that request. So that'll be coming up here in a second. But you can see the 700 or so URLs have actually had all their HTML fetched. And it took 3 seconds. So I'll just do that again. Look at this. Boom. That's a 700-page crawl in under 3 seconds. Because, thank you, Uncle Bill, I guess, in this case. It's a Microsoft thing. It's Microsoft bought GitHub, and so what if we crawl 700 pages and it's GitHub IO over and over? They could use, throttling software intrusion detection stuff, whatever. But I'm going to assume it's just fine. People do this against GitHub all the time. So what I need to do is, instead of just the response objects, I want this to be a list of tuples that have the URL that made that request. Because, you know, I could get it. It's in there. Watch this trick. List comprehensions. X for X in vals, right? So it's the same thing again, but now I can say .url. Whoops, did that the wrong place. .url. And there's all the URLs that were part of the request. So it's like they're in there, they're actually in there, but I'm trying to make this a generic tool. I don't want to rely on the implementation of HTTPX to have a URL property so I can see what really made the request. In fact, it doesn't even come out as the string it went in as. It comes out as, what is that? Oh, name tuple with a single value. So, you know, probably a name tuple. There's a few other ways you can get a tuple to have an object name in front of it. I think data classes and stuff. But I don't want to have to rely on the .url of the returned object. That's just stupid. I want to use what I used to make the request to put in the first spot there. So that's where things went wrong, trying to go from this to this. But there's some very easy tests. First, another nice control, because we want to make sure we can do it over and over. This links thing has already been run. We don't need that there. This, nice. See, we have the ability to repeatedly do that. Okay. Now, this gather needs to be fed a series of actual inputs. It has to have the async. I probably can't mess around with this. I'd like to feed in a list of tuples to gather and splat those tuples into gather, but it doesn't seem like it likes that. So to show you what I'm trying to do here, you got a list. And so you've got list comprehension. And with list comprehension comes the ability to turn the returned value into tuples. Now this is just a single value, so it might be stripping it out. But if you force it with a comma, there's your tuples. I'm trying to force it with a comma. Well, that's an interesting thing. Let's see if I just use a comma next to X. Yeah, it doesn't like that. It definitely wants a parentheses. In some places in Python, you can get away with leaving out the tuples parentheses. But here, there's definitely order of operations grouping in list comprehensions that they don't, there's overlap of concepts of namespaces going on here. So parentheses are being specially handled. List comprehension and the comma is required to make it into tuples. So my test right here is not merely to put parentheses around it, because as we see, that's not good enough. I need to put comma right there. Error, right? And it's going to be that same error. So any attempt to tupleify it here is going to fail. Okay, but that's what's necessary for this concurrency trick. So what gets returned is RV, and RV is not awaited until a later time where it returns all those promises, where it executes the promise. I can make it so that the promise is carried out before the return, but that kind of gets rid of, that makes it then not behave like an asynchronous function. Oi, splatting the output of a list comprehension into gather. I need to know a little bit more about async IO's gather method, right? So what we're interested in is async IO gather. gathering the output of stuff. And putting like wrapping around stuff aside from the functions that are being executed, because I am executing in the equivalent of this location a httpx.get method. All the gather references are in that local area. So this is a real function that returns future object. It's got, so gather is really functions that return a future object. And so when that is executed, I need a wrapper function. No, because the whole apparatus, I was thinking of a wrapper function on HTTP get or HTTPX get, but the whole point is that there's a reused client inside the context manager that's using an async keyword. This is some powerful voodoo. The fact it's a promise can be used to, populate database later using a very memory efficient way. This stuff doesn't have to be memory bound or even hard drive bound. It just dumps directly into your database, which is a very appealing thing, except I need what gets returned to be more than just the output of gather, await gather. Can that, think it through. You're awaiting the gather, so that await was used, but it's still a promise when it gets out of here. Maybe I do want to await RV and not require await out here. Let's try that. I think it'll still require await. So let's just say this is now a promise. And return value equals awaiting the promise. I'm hopeful. Now we have to get rid of that. It takes no time. I don't believe it for a second. Yeah, it needs to be awaited. A promise. That's the already awaited error, so just run it again. No, do it fresh, maybe. Object list can't be used in await expression. Object list can't be used in await expression. Val equals. Oh, object list, maybe it is a list. Maybe val equals await. Object list can't be used in an await expression. Oh. Object list. But then how do you feed a list in? Okay, well, I really haven't tested my original concept by getting rid of the await there because that promise misspelling was in there. So let's try this. And as I thought, that is still a coroutine. Yeah, this is not the way to do it. So close, right? So close. I just want to get that key. I want to keep things coordinated. Whew, there's another way potentially to do this. I just hate it. It's ugly, ugly API. First, we assure ourselves we at least have what I had in the last implementation. And I do. So one of the things that can be done, and I'm a little bit nervous about this, is zipping values together, because this has to be the exact same number of elements. And then I'd have to maybe make a wrapper function for anyway. What I'm talking about is, since we have our links and we have our val, we should be able to just throw the zip keyword around it, because it's two lists that we're trying to bind together. And then you know, because things zip together, can be either dictionaries or different things, I'm just going to say tuple. And there you have it. See, the URL and the response, URL response. This is actually what I want, except it's it happens after the request has been made, and I don't have 100% confidence it's going to be the same number of items out as it is in. Let's assume it is. Let's assume it is. 80-20 friggin' rule. Gotta use it. It's a tool. So what we really want to do is formalize the doing of this in the calling of the function. So if I were to actually make a non-asynchronous function that wraps that other one, what I'm talking about is, ooh, yeah, def, I'm just going to call it get resp. And it takes as its input a list, it gets a bunch of responses which exist as a promise, and then it waits on the promise to actually do the work. And then RV equals tupleifying a zip of the original input of a list and the responses. So this could be a little helper function. You can't, no, wait. See, everything has to be synchronous or asynchronous. There's got to be this bridge. Ugh. Everything. So it's like all this catch-22. Async and await keywords put asynchronous behavior as if it's synchronous behavior, but you have to keep all your functions compatible. And when you want to cross between those two worlds, you get errors like this. And the thing is, it just can't be in a function. That's so weird. So what I'm really doing is get rid of that. It didn't work. The premise is wrong. Get rid of that. And keep this around for just a short bit. You know, the good shape. The good shape that I'm trying to get is this. So this will show me how long it did, and then it'll have the good shape at the end. Do a one-page crawl of my site starting now. It took 3.3 seconds, and now inside of good shape I have the key value pairs. And so that's actually a crawl of all those 700 pages, right? I could see the text of any of these pages. These are keys to a database. So I could take this, right? And I could say, now in that object, oh, well, it hasn't been turned into keys in a database. I would do that now. Actually, I can do that now. Now that I have this logic done, I'm going to show how this goes into a database. All this name tuple stuff you don't really need to see anymore. It was good while it lasted. We might get back to that again. And so now I take the database logic of dumping everything in, where this actually executed the crawl on each one. We don't need to execute the crawl. We're just going to shove the data in. We'll start with that sequential database logic. But instead of this is the dangerous one because it actually makes the request. It's not going to be for links and links. It's a good shape we're sitting on. For a tuple in the good shape, I'll comment everything out just so that you can see the link getting printed. If I were to just print a tuple, you would see the whole a tuple be printed out. But we're going to be using the left side of that tuple as the key and the right side of that tuple as the data. So I could print the left side of the tuple by just grabbing the 0 index of that. So there's just the keys, right? So now you get some idea of how we're going to do this. If you wanted to see how big the data is that I'm really honestly sitting on top of, I could print the length, because we don't want to print the whole thing, but we can print the length of what's in that position, but it's text attribute, because I know that the length of the object itself doesn't make sense, but the length of the HTML, the view text, makes sense. So here is some familiar numbers, and whereas these numbers, the last live stream video I made, these numbers were the same over and over, you can see they vary delightfully so that I know a crawl actually occurred. So now let's plug all that into the database. Now, funny thing, no file locks. Here's that 7 megabyte database. Delete, gone. Okay, nothing of a big file size in here. We'll see it come back in a moment, because we are going to be taking the database and we're going to be taking a tuple 0 as the key and a tuple 1 as the data, not just the text, but the whole object, because it's got value. And we will database commit. Let's do that. And after that's done, we'll see how long it took. I guess I gotta scroll to the bottom of that output. Didn't think that through. Yeah, it took 5 seconds. 5 seconds to push all that data back into the database. And there's the file. It's 11 megabytes now, 11.8 megabytes, where it was barely 7 megabytes before. So the real crawl made that data file larger. If you can't see it there, we can LSLA here again, find the A thing, and there it is, being reported as 12 megabytes. Because of that byte reporting difference between Linux and Windows on the desktop. Yeah. So that's kind of close to mission accomplished. It's just not the API that I want. I don't want to have to do these 2 steps. Forget about the start and stop, right? So copy, paste. The way this would have to be done is for you to get your promise and then await it, get your awaited promise and take the resulting shape and zip it back with the input that you used here. And it seems to me that I should be able to do that here, except something about this whole await gather eludes me. And it's going to be even harder when I get to the other side of this thing, where when a function is provided and it's tuples in there. So I'm not really sure my next step, but I know I brought it to a very good point, which I will now commit and start later because I got enough done to be happy here. nbdev clean nbs. I'm not going to put it into the exported package, but I'm going to git commit async crawl underway. Git push. And that was a really important bit of code. I'll knock this last piece into place, but the complexity is now not actually on the asynchronousness of it. I'll have some error handling to put in here. There's some error handling. But honestly, these two lines right here are the $1 million lines. This is what Python has such a bad reputation versus things like curl and JavaScript in making lots of concurrent requests fast. But I'm here to tell you, Python is just as good as any other language at making lots of HTTP requests, firing them off fast. Maybe not as good as a truly parallelized language, taking advantage of your multiple cores. But list comprehension, you probably could do it through Dask and take advantage of your cores. But the difference, because HTTP is your bottleneck, the difference between this and what you would do if you allowed multi-cores get thrown at this is not enough to make it worth it. Your bottleneck is the HTTP protocol. So allowing a single CPU to make multiple requests while waiting on bandwidth, delays is the 80-20 rule. This is the big win. So there's a big win here, and I'm pretty happy with it. So let's see if anyone tried chatting to me through all that. Probably not. Yeah, look, I've had some concurrent people on there. Oh, hey, someone said something. Prefer HTTP over async IO. Okay. Interacting with people. Or AIO, rather. Yeah, Pat, you corrected yourself and said exactly what my response was going to be. So the answer to that is, of course, async IO is part of the standard library. This is what's built in. But just like URL lib 2, URL lib 3 had a not great for humans API because of edge cases, same with async IO. Very few people use it directly. So AIO HTTP was the first high performance one out there, and I tried using it. I would not knock it, but honestly, compare what's necessary for AIO HTTP to what's necessary for HTTPX. Try and think it through. Now, there's still some mystery to me. I still got to get down promises, the handling of promises here. Everything needs, But aside from the little bit of API syntactic magic that's going on in here that I need to clear up in my mind, it's just 2 lines. It's just 2 lines, and it's the context manager, which makes me very happy. It implies a whole bunch of interesting things. It has, and it's got the requests, it's got Kenneth Wright's requests API. So I recognize all this as how one might do session, right? I'm going, a client, that's a session object. And so, and there's list comprehensions here. It's all fitting together into the least complicated mental model for concurrent HTTP requests that I've encountered yet in Python. AIO HTTP is not as straightforward. In fact, if I went over here and tried to actually, AIO HTTP, find that example for lots of URL requests, I don't think I'd have quite as easy of a time. So context operated session. Okay, there's some recognizable stuff. Async with session as response. Yeah, well, in all honesty, I did not find that that gather use, I did not find the list comprehension gathering thing here in the documentation for HTTPX. I had to go hunting for that. So maybe AIO HTTP is just as good. And if this same trick is used under their, asynchronous context manager, which is what it looks like here, it would be the same. Maybe it's just a matter of I found the examples on HTTPX, but maybe other people can chime in and help clarify my thinking on that. But me happy with HTTPX. It's a newer library than AIO HTTP. And this has a good reputation for high performance. It was my first thought, but boy, I could not get the magic happening. So that answers that. Let's see if anything else before I wind up here. Yeah, okay. I don't know if Pat's one of the ones who's actually still with me. I guess no one is. It's 0. So thanks for joining me. Hope to see you again soon, and don't forget to subscribe.